My name is Nicholas Dritsas. I'm a principal program manager with the SQL Server team. And unfortunately, you're going to bear with my Greek accent for another hour. Or I can speak Greek and I have no accent. Have any Greeks in the audience? No? Okay, I'll stay with English. I'm part of a small team we have in SQL Server. It's called Customer Advisory Team. The goal of my team is to work with the most exciting, interesting, bleeding-edge projects on SQL Server around the world. So one of the goals of my team is to come back and produce all these nice white papers and in MSDN and books and things like that to share with you what we actually see other people more adventurous than you do with SQL Server, so you're learning and you don't have to do the same thing. If you haven't visited our website is SQLcat.com, SQLcat.com. It's one of the most busy SQL sites out there. So that's where we publish a lot of our material. Okay, so today the topic is around integration service, performance design patterns. Integration services has a lot of features, a lot of tasks. We keep improving the product, and we're hoping to improve it even more in the next upcoming releases of SQL Server. But today we're going to discuss more around some design patterns we see that hopefully you'll use them as you're optimizing the performance of integration services. Just to get a feeling, how many people are using already integration services? Okay, you're in the right class. So I'm assuming you know integration services. So some of the general performance tips, of course, a good design, a good package design is the key of the whole story. It's very nice the idea is to design it properly from the beginning to establish some design patterns that you know they're going to help you instead of troubleshooting it real time, because that is going to be much more difficult to catch up the problems. Use the appropriate tools. So integration services, it's a very nice workflow, transformation environment, an engine, but don't forget the database engine. So many optimizations we've done in the past, and we'll talk around it, is knowing at which place you can use more properly, take advantage of the database engine features and abilities. So calling transact SQL or store procedures within SSIS can give you a lot of performance improvements. And then take some scientific approach to measuring and tuning your integration services package. It's an iterative process because as you're introducing a package in your production, you're learning. You see the patterns, you see the perhaps the deadlocks or the blocks. You need to have some kind of approach that you can bring those findings and measurements back to your package and see how you can tune it as you progress. So we'll talk about how we measure the performance of a package, how we modify it, and how we remeasure. So we need to put some kind of check and balances in the integration services package to give us this ability to improve its performance. So this is one of my classic things I do when I start building a package. One of the first things I want to do is to create some benchmarks, create some history of how things are progressing every time I make some changes or introduce new things into my package. So what I would like to do is when I start at the very top, I want to, for example, in simple terms, get an initial space used for some particular tables to see how many rows I started with. And then we're recording that. And then at the end of my package, at the very end, as an approach, I end my trace, get another space used, and I record that. So that kind of gives me an idea from performance, how many rows I inserted, how many kilobytes I added, etc. I could even start a particular performance trace, go down to the trace level and end it. The idea is then this trace is associated on time and date with this particular package run, and you can see the impact as well on I/O, CPUs, and all the stories. So the idea is make sure you establish that at the very beginning, at the very end of your package, so you have some benchmark placement where you can even add additional points to capture, maybe memory used or CPU levels used. So this is a sample report. As you can see, it's a reporting services report I generate out of those benchmarks. It gives you some kind of step line. This is for a data warehouse ETL process. And you can see there the different steps where we're updating the dimensions and the facts at the bottom. And this is some of the standard benchmarks you can capture, how long each step takes, kilobytes per second and rows per second consumed. So the idea over here, of course, from your benchmarking story is as you're seeing these reports day by day, you should be, that's your baseline, you should be within those parameters. Otherwise, you have to do some tuning, maybe some indexes or some issues. At least you know the step that is out of your traditional baseline, and you can focus your debugging efforts much easier. Okay? So let's go through some topics now, specifically for SSIS. This is 2, 4, 6, 7, and I hope we have time to go through them. Otherwise, you have the slides. This is some of the key items that we encounter when we're tuning integration services packages. We'll talk for the parallel processing and how that works well for us, when to use database engine, the new feature around change data capture. That's where we can consume deltas easier. How to address slowly changing dimensions and late arriving facts. We have some strategies in SSIS to deal with them in an optimized way. And lookup cache and null value substitution, because that's another key element. How do you handle multiple nulls in big tables? By the way, I'll be talking fast, so if you have a question, react quickly. Raise your hand, throw chairs, peanuts, whatever. Peanuts preferred. Okay, so for the parallelism, let's talk for parallel processing. Parallelism pretty much, we can add more hardware, we can have more parallelism. SSIS 2008 and 2008 R2, we very tune around multiple cores and high levels of memory. We do expect to have those. It was not the case in 2005. 2005, we were very stingy on how many threads, multiple threads to issue, actually up to 5. That was our internal threshold. Then everything else would queue. In 2008, we have really parallelism for multiple threads based on the number of cores and the configuration you have. So the idea for parallelism is to divide my ETL task into distinct operations. The distinct is it's important because we should avoid or minimize to have any kind of overlap between those operations. A classic example in data warehouse is you want all the dimensions to be processed in parallel because they don't really depend on each other. But the fact table, you want it to be in sync after all the dimensions have been processed because you need to pull the new surrogate keys for the new fact table. So that is an example I was telling you. This is where you're kind of grouping, and it depends on your application. You're grouping distinct operations. So, for example, maybe you need to process the region on its own first, then the nation, then you can process these three in parallel, and then the other one at the end. So going through your business logic in a way and establish those boundaries across operations will help you to drive those parallel operations. Here's an example of a parallel control flow tasks. Out of curiosity, can you guys see it in the back? You can? Oh, you must have sharp eyes. Or my eyes are getting old. All right, so this is a scenario where we have kind of two different concepts. Here is fairly serial kind of process. One works after the other, different data flow processes. Here it's a little more parallel, where those two running in parallel, and then upon execution of both of them, we go into a particular sequence container that goes through some bulk inserts and some particular data flow tasks. So SSIS allows you to create those boundaries. Even within containers, we have a new task that is called sequence container that encapsulates all these processes, and it gives you higher level of parallel control. To be more fancy, I mean, we don't have to go through all this picture. It was a cool picture I took a few days ago. The idea over here is that we have a nice new task that is called multi. the multiple executions. So this is an example of a large telco customer. So what the telcos guys have? These guys is a mobile company. They have a bunch of towers, you know. The towers, cell phone companies. And the telco companies are the best. I mean, they take advantage of BI like nobody else. Maybe the retail is close to them. But the telco guys, the moment you connect, boom, they know who you are. They know it's the big brother. I mean, they know everything for us. It's pretty scary. Now with all the GPS-enabled phones, actually, they even know every time where we are. You think your GPS is off, but it's not off. I don't know if they have that in New Zealand, but I live in the Philippines. And one of the features they're testing is to allow me to know where you are. So I say, I know your phone number, and I say, where is this phone number? And they send me back a map with your location. That's pretty scary stuff. They can find where you are. It's still a privacy issue, so you have to accept that. So it's a kind of a two-sworded thing. If you say, I don't want you to see where I am, I don't know, maybe that implies things, but there are some, why you don't want me to tell you where you are, dear? So these large telcos, so you can imagine the amount of data that potentially can pipe in SSIS through that. We're talking, these guys, to give you an idea, they want to load 8 terabytes every day of information. So that's a lot of data. So imagine you're an SSIS developer, and your task is to build a performance system that loads 8 terabytes. And of course, if they tell you, I have 8 terabytes today, probably you should plan for 15 terabytes system in a day. That's pretty daunting. So the way this guy's working is, they have a couple of 2 big Unix switches, maybe more than 2, but they're Unix switches. Actually, about every 10th hours, they correlate to one Unix switch. It brings all the data information over there. And then we grab it with a bunch of FTP files, and we bring them across to the SQL server. So today, this company, they have a farm of 64 SSIS servers, distinct servers, running 64 processes in parallel, mapped to particular areas of towers to extract data. We're about to release 128 servers, blades, to deal with this process. And I'm sure you have many questions, many theoretical questions. Why do so many servers? Why don't you do virtualization? Why don't you do multiple instances? These guys, it was, money is not an object. I wanted to make it fast, no blockings, whatever. And it's pretty nice with the blades, because now an HP blade, this big rack, you can put up to almost 90 blades, 1U, in one rack. So it doesn't take too much space. Of course, you need a lot of air conditioning. But actually, we have an air conditioning unit on top of each of these racks. It's so hot. The bottleneck at the end we found, okay, we solved all the problems, parallelism, happiness, things are moving fast from left to right. You know where was my bottleneck at the end? What is typically your biggest bottleneck when you're moving data? I'm sorry? I/O. I have 2 shirts to give away, so you grab one. It's 1 shirt left, size large, so think small. Okay, so I/O, it is my bottleneck, and that will be, it's a whole other session for I/O. Do not forget the I/O. It is not really apparent to your SSIS tuning, because you send the data to your destination and you think you're done. It's on the destination, things will take care of that. But still, that affects your SSIS performance. We try to do some things with the solid-state drives. With them, we're experimenting if SSD will help. EMC just released, they're calling it EFD, Enterprise Flash Drives. It's a SAN, all SSD. Very, very interesting, very expensive. But we'll see. But this is the bottleneck for these guys. And then at the end, we're loading all this information. We do the load into a fast-track system. Actually, they're using a fast-track data warehouse system for queries. So that, just to give you an idea of some real-time environment where they're introducing a lot of parallelism, not only within the packages, but also, remember, across the servers. So they're splitting the data loads into 64 physical pieces, and then we have 64 servers receiving this stuff and loading it. All right, so quickly, best way to improve performance, divide in distinct operations. Keep remembering that. Get the big picture of your package and see where is the dividers. How can we group them together? We have some built-in parallelism as well. It's not only across servers. Within each integration services instance, you can control max concurrent executables and engine threads. This is something to control a little if you want to lower those levels, primarily, lower, so you let the parallelism be true and not queued, especially if you're sharing SSIS with analysis services or reporting services or some others. If you have other services running on the server, you may need to decrease those levels. And the work pile pattern, I encourage you for that, for large scale out solutions, especially when you're dealing with multiple packages. That gives you more control to establish priorities and see better how the process works. All right, so this is a word, I'm sure it's not in English. SSIS is awesome, but SQL engine is awesomer. I didn't write that. It was a guy in the US that wrote it, so I thought he knows English, but all the spell checkers scream about it. So SSIS primarily is an in-memory ETL tool. That's the big difference. You are in memory. There is the concept of pipeline. No? You're loading the data, it stays in memory. Truly, it is treated like a data set. A task doesn't care if it's in memory or it comes from the disk, it's still a data set. But primarily we're in memory, so we have some limitations within the memory. Database engine, though, is optimized for a couple of things that SSIS may be a little overhead, sorting and joining. We'll talk for those two things. These are very heavy operations, especially if your data set is large. One approach we do is to stage the data and avoid OLEDB command when possible. SSIS in several operations, and we'll talk which ones, it drops down to the row-by-row level operation. Row-by-row level, as you can imagine, is pretty expensive. So we talk for some strategies to stay more on a set level, because that is going to improve the performance a lot. Typically, when you involve OLEDB commands in SSIS do drop down to the row level process versus sets. So we'll see how we can bypass that. Staging data is an idea. You're creating a staging table on the SQL server, and then you're using that kind of your cache versus the memory cache. Actually, that's what I just said. The idea is you have a source, and then you're putting in some temporary staging table, and then you do your SQL task, and then you're loading into your destination. But we'll go in more detail shortly on that. So we're going to discuss for three very heavy and potentially performance issues candidates that you should be aware of. Keep an eye on them. I'm not saying don't use them. I'm saying keep an eye on them, make sure they perform well. If they do perform well, fine, but these are the first candidates to look for. One is the sorting. We have a task in SSIS that allows you to sort data. But to sort the data, what I must have to do? I must first read them all. So SSIS is not like sorting as it goes and then shuffling pages and shuffling pointers. SSIS has to load the whole data set in memory. And not only that, many times you have to hold a lock on the source. That may be not good. Okay, we've seen some cases, some deadlock situations, because it's holding a share lock. So the reads are okay, but the writes on the source may get affected. The idea over here is to keep a consistent sorting. I need to make sure there's no new data coming in, and that I have to read it again in memory. So if your data set is small, or your source is fairly read-only, that is fine, but otherwise we may have some problems. And just be aware of the sorting. Aggregate, that's another function we have in SSIS. It allows you to aggregate data by doing sums, doing some counts, doing some things like that. Same problem. I have to read all the data and take a share lock on the source. It may create some blocks. How do you pass that? We could use, as we do with sort, the idea is we're using the SQL side. SQL has order by for the sort. SQL has group by for the aggregates, and we can get sums directly out of SQL. Merge join, it's another pretty heavy also task. Again, keep an eye on that. Make sure we don't have any blocks, any high performance issues. If it does create an issue for you, then we can revert again. We're talking here how SQL can help us. SQL is very natural on doing joins. I mean, the whole SQL language from the very beginning, it was done around the concept that we can join tables very well. So you do have sort, aggregate, and merge join tasks in SSIS today. If those create some issues, especially keep an eye on the locking, you could go back to SQL syntax and use order by, group by, and the traditional joins. Okay? SQL, again, can give us a lot of nice features. Let's talk a little more for merge. Merge is a syntax we added a few years ago, I believe in SQL 2008. We used to call it upsert. Actually, we didn't know how to call it. So the idea is it's one statement where it controls the idea. If there is a new line, insert it. If it's an existing line, update it based on a particular key. So in the past, before we added the merge task, you had to go to the OLEDB source, do a lookup, and then do that kind of conditional split. If it exists, do an update. If it doesn't exist, do an insert. So that was a pretty heavy process, especially that lookup, because that, as you realize, it's immediately a row-by-row process. Every row I have to take it in, evaluate it, and then do all that. So it works, but it's very, very slow. So we're putting a big no-no there. Don't do that. If you really want to do in SSIS the merge, what we suggest, and we're talking, I assume we're talking on a scale. Typically, this conversation implies tuning and performance, so typically implies large scales. So the strategy I would suggest is we're creating a staging table, and then we're putting all this data into the staging table. This is, in a way, the new data, and then you're running the merge statement. So that implies, again, we're running SQL. We're not running SSIS packages. So how this merge thing looks like, we'll look at that very shortly. Actually, it'll be my next slide. But the merge statement, it gives you the ability to take as an input this staging table you just created, which is all the new data, and then you merge it with the existing data, and then you're running this scenario. At the end, it's a merge command, not insert or update. It's a merge, and it's a set command. It's extremely fast. Review. So the idea is to take advantage of the database when you can, using store procedures, using transact SQL. There are very good places where SQL, traditional SQL commands, will give you very good performance. So what we've seen so far is merging, order by, group by, and joins. In many cases, this gives me very good performance improvements over SSIS. To go a step further, I don't think I have it in my slides, many times we find problems with views. When I use a view from the source, that view sometimes, because may not have the right indexes materialized, that can be a bottleneck for mine. So as a strategy, I know you don't have this ability many times to do that, but we like sometimes to persist the view into a table or materialize the view and then create some indexes on that, so that can accelerate the process as well. Staging overall is helpful. Some places they even have a separate database by its own, a staging database. By having a staging database outside of your main database, what you avoid is you avoid fragmentation on your main database, because staging typically receives a lot of information, you use it for a while, then you drop it. This constant adding and removing, it adds a lot of fragmentation in the space, so you might as well keep it within a separate database, because if it gets really fragmented, my suggestion is you drop the database and you create a database, and then you have a nice clean area, again, without affecting your main database, okay? I/O is always a thinking on every decision you do, because fragmentation will introduce a lot of I/O overhead, because the little head in the spinner goes back and forth, and your I/O goes really bad. Yes? So the question is, should we put the staging in another database? Or do I always do that? Or put it in a separate file group, you suggest? But the goal is, okay, so let's see. The goal is to make sure we minimize fragmentation on the main database. Absolutely, I could put it in a separate file group, make sure my files reside on a separate LAN than the LANs of the other file groups, and be diligent enough to create the staging tables into that file group, which is probably not the default file group. Yeah. Typically, that's what I forget. I don't put the file group name in front of my create table. So that's all. By having it, the only nice thing is by having it in a separate database on its own, you could have perhaps another security even scope in that, more open to everybody kind of deal. You have your own log as well. So if you worry for transaction log getting too big because of staging, too much information, you may even want a different, typically staging can be in a simple mode when the other is in a full mode. So, it depends what you like. Yeah. Any other question? Okay. It's getting lunchtime, I think. Huh? All right. So we're saying avoid sort, aggregate, and joins within SQL, within SSIS. I'm worried for the blocking. Try to use the SQL elements from that. And we're going to use the merge. Now, Codeplex is another site. How many of you know Codeplex? Okay, quite a lot of you, but several of you don't know. Codeplex.com, that's the full website. This is the site where Microsoft and everybody, the whole community, can publish samples, source code, interesting utilities, whatever. So if you're looking for some interesting utility or code, go over there. Go to codeplex.com and search. It's pretty rich environment. All right, change data capture. So let's talk about that a little. More data, more problems. So we live in the, you're hearing these presentations and everybody tells you somehow you get the data and you load them every day. And then you go to your job and say, okay, so how somehow I get this data, especially the daily delta from a system. So the daily delta is always our goal in SSIS package. You want to get this incremental load every day, because otherwise if you load the whole thing every time, it's going to be too much, and they're going to blame your SSIS packages anyhow. So the idea is, as a goal, is to reduce the amount of data you're processing. We need to find techniques and coordinate many times with the source system how to get this smaller amount of data to come across. So we want to filter out any unchanged rows as close to the source as possible. So the idea is, ideally, I don't even want to get from the source the unchanged rows. Then even if I get it, maybe I get it on the staging or somewhere. I mean, the idea is to don't push them all the way up, and then you find them, okay, I joined with a fact table and they are there. That is too much. You have to carry all this information through the whole pipeline for no reason. You want to clean them up and remove them as soon as possible. So a couple of factors that can affect that very key important solution, how you can minimize the data you process. Is my source a relational database? That, of course, much easier to do that, because if it's a flat file, it's more complex. And can I change my source schema? Can I introduce some new columns that will help me to get this data, the delta data, easier in the system? So some of the traditional approaches, oops, sorry, that's a little white on white there. We can add audit columns in the system, which can be a modified flag. Have you changed, has this record changed or not, and you can query that. Or you can do the checksum. Checksum, you can do it even real time. You know, in SQL Server, we have a checksum function that you can compare, get some kind of value that compares that value to the existing value of the record. Existing value, I imply, this is what you have loaded already in your data warehouse, for example, and you can capture the checksum of the source. Much more complex than traditional, because you have to read all the source and all the target and compare those. Log scraping, this is when you scrape the transaction log of the source. We don't have a tool like that in Microsoft, but there are plenty of third-party tools that they're going through the transaction log for the day, and they extract, kind of a replication style, they extract all the statements, insert, updates, deletes, that were done during the course of the day. So in a way, you can replay those in some staging area and get the deltas. More elegant is if we have, of course, a last modified date column on my source, where I can simply, query and say greater equal that date and get the delta. And we can go down to the database level. There are some utilities where they do database diff. This is typically a good idea if your database is fairly small size. So you have to scan both databases and give you the delta. Those things like log scraping or database diff, this is pretty much when you have no access to change or touch the source, if it's a packaged application, for example. If it's not a packaged application, if it's your application, maybe you add some additional flags in the system. So in SQL 2008, we added a feature that is called change data capture. Change data capture is fairly transparent to the application. Actually, it is transparent to the application. And what we do is we introducing behind the scenes a new set of tables, NDMLs, where we capture the history. It's kind of a record logging or on a record level, like history of the changes of the record. You could query those system tables directly, but the best way to do that is we have a number of DMVs that you can go and find and answer to questions like that. For this particular table, shows me all the changes that were made up to 12 o'clock or between 12 o'clock and 4 o'clock. So when you enable CDC for a particular table, the system is going to generate that kind of hidden system table where it tracks all the changes of the rows. And then you can, again, either query the table directly, or what I highly recommend for you is to use the DMVs. We have DMVs. You know what's DMV, no? DMVs, the views that you can answer, you can select, start from that particular table. Now you could do selects, or we could do SSIS. SSIS is aware of a database that has change data capture enabled. When you do that is pretty much we have from these changes, we have to create three paths. Pretty much we need to understand what has been deleted, updated, or inserted. Okay? And this is a decision also as a developer you have to make, because within a day a record can be inserted, updated, and deleted at the end of the day. So you as a designer, you want to know, do you not only to extract those operations, but would you like to know the last operation that happened for the record? So if you're creating a daily load for your data warehouse, maybe you don't load that row at all. If it was inserted, updated, and deleted, why you need to do all these three? Unless you do, but the point is you need to understand also the sequence of the events when you do CDC. So what we do is, when we go to a table that has CDC enabled, there is a particular condition. This is a particular code name that says the underscore CDC operation. This is a hidden column where we capture what was the action that it was taken for this particular row of the table. So we're creating 3 inputs. That's a conditional split, and we say if it's I is insert, if it's a UN is update, and if it's a D is a delete. So simply by reading the table, you don't have to do the DMV apparently. You're reading the table, and based on this column value, you know what action you can take. Okay? So CDC is very helpful. It's very lightweight, and again, it gives you this versioning, the versioning of the rows through the course of the day. It can be very granular as the changes occur. All right. So less work and less data means we're processing, of course, the processing time is much shorter. So our goal is to get as less data as possible. Please, please, please spend a lot of time designing and understanding that. How can you get the less data as possible across? As for alternatives, again, we can use a checksum, as we said, enable the change tracking system, and we have Attunity. Attunity, have you heard of Attunity? No? Yeah, there's one. So Attunity is a third-party, it's a company that makes very fast, optimized providers, drivers for data movement, for data extract and loads and all that. So in SSIS 2008, we added already a few, we licensed some of the controls to get fast data extracts from Oracle and Teradata. So that comes part of the story. What Attunity themselves sells, they have their own solutions for CDC, especially for Oracle. So even Oracle as a source, using an Attunity provider, you can capture the changes, the records as they change it during the day, and still use the same process to feed the data within SQL. So something to keep in mind. If you have an Oracle source, you can still go and see the delta changes of the day by using an Attunity provider for that matter, because Attunity provider, all the providers of Attunity can be plugged into SSIS. So even if we don't ship some of them, if you buy from Attunity directly, those are compatible with SSIS. All right, slow changing dimension. So slow changing what? Who've heard of slow changing dimensions? Wow, quite a lot of you. So how many types we have? How many? 3. So type 1 is? Simple terms? What operation you do in type 1? Update, which is pretty evil in the database world. You update. Ooh. What is type 2? Insert. What is type 3? It's version. You kind of version. Now, you know Ralph Kimball? How many know Ralph Kimball? Okay. You should know that guy. He made some of our living through. He's the data warehouse, one of our data warehouse authorities. So he's talking for, you may hear it since you work in this environment, it's called type 1.5. So it is an update, but not really. So the story is, you have a record, let's say, of a customer, like you're filling out some registration sometimes. And in purpose, you don't put a lot of your information. You're skipping address, phone numbers, things like that. Maybe you give a few information. So this is a record in your customer dimension that you can flag that is not really ready to be a type 2. It's still a type 1. So even if I receive updates for this record, I don't want to change, I don't want to treat it as a type 2 because I still don't have the full information for this person. So you're receiving a bunch of updates from different places, correlations. When you reach the level you assume this record is fully populated, then you change the flag and you say, okay, now I'm type 2. So when new changes come, then you do an insert. then it's a true change for this record versus receiving, still having it in an update mode. So you can have an update mode or an insert mode within the same dimension. I don't know if he's going to call it 1.5 or type 4, but something that is going to come out soon, and we support it. So slow changing dimension is a key for most data warehouses. This is a key decision to make. How do you handle a slow changing dimension? And because that affects what? Why this is an important decision if you're going to make an update or an insert. Historical data, exactly. Because the historical data will change or not. Actually, it will be grouped properly. If you do type 1, you're moving the whole history in that bucket of the update. If you do an insert, you maintain a proper segmentation of the history. So SSIS has built-in support for slow changing dimensions. It's easy to set up, but in some cases we may face some scalability issues. We do have a nice wizard that creates proper packages for you to handle that. But let's look some tricks over here on how to make it perhaps a little better to perform. And the third-party components, we'll go through some of them. And of course, if everything fails, you build it yourself, you publish it to Complex, and you get fame, and well, that's all you get. We don't have a market for these things. We should have a market. Okay, so this is the wizard that comes in SSIS. It's called a slow changing dimension wizard. And the idea over here is you're pointing to some dimension columns. This is your dimension columns over here. And then that's where you specify the type of the change. So you can say it's a fixed attribute, something that doesn't change ever. And that is actually a check control. That establishes a constraint. So if that changes, or you try to change it, the system will fail. You cannot change that column. That's pretty cool. We don't really have that in SQL unless you put some triggers to not change the value of a column. No? So birth date, for example, hopefully that's a fixed attribute. Line 1, line 2, here we consider it as a historical attribute. And then the phone is a changing attribute, which is a type 1. Over here, actually, we're describing, I should have read that one. Type 1 doesn't change. Actually, it's updating, and type 2 is where we're doing a historical type 2. So by establishing this metadata for each field, that gives an idea to the wizard how to treat a change in this column. And the wizard, at the end, produces a particular SSIS actual package to handle these changes based on the metadata you provided. So there is this particular data source that gets information. It goes through the slow changing dimension task, and then it produces some updates, some inserts. It expires old record, and then goes down to that. So this is a result of the wizard. When the wizard produces the package, that's where it's coming from. I want to go to more, yeah, that's what we just said. I want to go to more details on the actual queries run behind that. But before I go that, this is from Ralph Kimball. Ralph Kimball has a component which you can download. You can plug this into SSIS as well. This is kind of a replacement of the SSIS slow changing dimension component, and it gives you kind of a similar concept where you specify if it's a surrogate key and what kind of slow changing dimension level you have, if it's a type 1 or a type 2, and then mappings and handling and stuff like that. It's a pretty good component as well. You can search out there and find it. That may give you another alternative how to manage the slow changing dimensions in your environment. So slow changing dimension using Kimball is using, again at the end, they're producing also a package after you go through the wizard, where it kind of takes the source data, the existing data, and then produces different actions for the slow changing dimension. So a natural thing you may say to handle the slow changing dimensions can be also the merge. The merge by itself, it is built primarily to handle type 2, potentially. Because if the value exists, the point is you don't have to do something. In merge, you identify primarily that this key, you identify if this key exists or not, and then you can make a decision. So if you know the primary key doesn't exist, that's an insert. If it does exist, if it's type 1, you do an update. If it's type 2, you do an insert. So you can make decisions using the merge. So this is the type 1 merge syntax in SQL Server, where you say pretty much you're merging into the dim product using some staging database. So this is the idea of the staging. In the staging, you're piping all the source information, because this is a set operation. It's not going to go record by record. Again, it's going to do the whole set at one time. Big time savings. And then we're joining on the alternate key. Typically, you're joining on the business key, as I call it, or the source key, not the surrogate key. Because in a type 2 dimension, the same source key has multiple records and multiple surrogate keys. So when there is a match, and the end date is null, that's a trick we're going to talk about. So for every dimension row, we have 2 additional columns, start date and end date. That's for the type 2. That tells me in which time period this record was valid, and that's the one I should be using when I query, when I join with a fact table. When the end date is null, that implies is the current record. So when you're updating, when you do type 1, you always want to update, of course, the current record, because you're overwriting the information. In a type 2 scenario, that's when you're going down to the decision in the merge pipe. You do an insert, you do a merge, and you do the joins, and then you say when they're not matched, the keys, that means it's a new record. Again, that doesn't mean you're automatically doing an insert. That, again, simply means you identified that key doesn't exist, and then you do something. Not necessarily insert, but typically that's the right action to do. So in my case, we're not matched. I do an insert. So this is, of course, becoming my current record. It's a brand new record. So the start date is today. The end date, it's open. When they match, and the end date is null, so I'm looking for, again, the latest current record. It's a type 2. So the idea now is not only do an insert, I want to close the existing current record. So I do first an update on the last current record, setting up the end date to today's date, and then I'm adding a new record with a kind of an insert scenario. So in type 2, I do an update and an insert of update the old record and then insert the new record with a new key. So that creates a new record for this particular key. So this is a single command, as you can see. This is very efficient, very fast, especially when you're dealing with big large data sets. This can run in a few seconds even and produce the results you're looking for. Okay? So that's a nice little sample if you want to do type 2 process. And I should have clicked through that because it shows nice pictures. Alrighty, so some comparisons we did, between the different, and I have little time left. This is in case you want to see, okay, what do I use? This is in your slides. As you can see, merge is performing the best. Bottom line, you see it's the far right column. The merge function is working quite well. So use that. Review. Replace OLEDB Goba. Another one is to enable fast load on the destination. When you create a destination table, when you're loading the data, there is an option, should I enable fast load? Fast load is a preferred way because we allow to, pretty much you take a table lock and we don't have to worry for that. It's a very fast load. Reuse connection as well. When you have so many components over there, sometimes we're opening some of the components, they try to open their own connection. You have an option though in the connection manager to enable reuse connection. So pretty much you're using one connection, then you're using the data cache and all these good things. So keep in mind on this reusing. Third parties, merging, we talked for that. Which one should I use? This gives you some kind of comparisons. Which one is easier, faster maintenance? I'm a favorite of merge, as you can imagine by now. Very quickly, late arriving facts. That's another subject to worry about. This is when you're getting facts. But you haven't received yet the supporting dimension information. You still don't have received the master or something like that. How do you handle that? So in my scenario, for example, I have an order date is 2002-601. That will correspond to a particular range over here. You see this is my type 2 dimension. So you have to join it using this particular syntax to get the right type 1 record. Some other fun stuff here. I'm going a little faster, folks, because I have 1 minute and another cut me off. This shows you a little, the difference between a lookup, merge, join, split. The nice thing with the lookup is that it's cached in memory. But again, ETL, as we're saying, is a memory-driven ETL tool, so you need to be careful there because you may be putting a lot of stretch in memory. Last thing I wanted to talk to you. So save the cache, save the world. Cache is very important. So some tips over here regarding the cache. We have Cache Connection Manager, which we allow both shared and persistent caches. I don't have time to go to more details here, but look closer to the cache, because especially if we have lookups, a lot of joins happening, this gives you the ability to do that in memory and save a lot of time in performance. It's not automatically on. This is something when you create a data set, you can go to the Connection Manager and establish what is the level of the cache. By default, I believe it's not on. But you can say it's persistent for this particular connection or is shared across different connections. Of course, that implies some memory limits. And the miss cache is off by default. This is the case, when some of the data you try to find are missed, they're not in cache actually. If you enable that, we're kind of learning, we don't find some data in cache. SQL is kind of learning and is putting that over there. It's kind of building a cache for you, so the query is going to go faster. Okay, I'm not going to go anywhere further because I like to hear a couple of questions from you guys. I think the next item I'm not going to cover is the null substitution, but it's very similar to the merge story. You need to find out properly where they are. I have 1 minute perhaps for a question or two. You all shocked? Yes? Oh gosh, so the question is, do I have a rule of thumb how much memory you should have for SSIS? It is like the $1 million question, I guess. It depends. I don't have an answer. The more SQL though you use, the less memory you need for SSIS. The more you want to become fancy with SSIS and ETL, the more memory you do. We do have a lot of performance counters, pretty much memory. Yeah. Oh, yes. The overhead? It's very low. The question was, what's the overhead enabling CDC on an OLTP system? I would say minimum to none. We're using X events to capture that, and X events is in the few nanoseconds kind of overhead. So we're dropping it down to the engine level. It's very low. Oh, triggers is much higher in the stack. That's why CDC is down on the core engine level. Yeah. Okay, thank you very much. Fill out your evaluation. Thank you.